In question 41, it says that the average kinetic energy of a body in one complete oscillation with respect to position is, where omega is angular frequency, A is amplitude, and m is mass of oscillating body. So we need to find the average kinetic energy of a body in one complete oscillation. We know that in SHM, kinetic energy is always positive if you move forward or backward. So it doesn't matter in one complete oscillation, either you take negative or positive, it doesn't matter, right? And we know that the kinetic energy at any position x will be given by half m omega square a square minus x square. This is our kinetic energy. We have to find the average kinetic energy with respect to position. So we know that when a particle oscillates, so the total displacement will be what? 0 to a, right? So if I want to find the average kinetic energy, we can write it like this: integration of k dx from 0 to a divided by total distance. That will be a. So if I put the value, we will get half m omega square. Since it is a constant, it will come out of integration. You will get a square minus x square dx from 0 to a whole divided by. So we can write it half m omega square by a square dx minus x square dx from 0 to a. So if I integrate it and put the limits, we will get half m omega square a square is a constant, dx integration x 0 to a, you will get a. So you will get a cube minus x square dx is x cube by 3. If you put the limit, you will get a cube by 3. So by solving this, you will get half m omega square by a into 2 a cube by 3. So 2 will cancel out, a will cancel out. You will get the average kinetic energy will be equal to 1 by 3 m omega square a square. So this is our final answer. So from this we can say that our option number 3 will be the correct choice. Now let's move to the question number 42. In question number 42, it says that a block of mass m is attached to horizontal massless spring which can move on a smooth horizontal surface. If it is slightly disturbed from its equilibrium position, then the time period of oscillation is. This is just a formula based question. Time period of any spring mass system will always be equal to 2 pi root under m by k. This is just a formula, right? So we can say that our option number 1 will be the correct choice. Now let's move to the question number 43. In question number 43, it says that 3 consecutive resonant frequencies of stretched string fixed at both ends are 60, 90 and 120 Hz. Then we know that the difference between the frequencies of 2 resonant frequency will always be equal to the V by 2L. The frequency difference between 2 successive resonant frequency or consecutive resonant frequency is always equal to V by 2L. And since it is a stretched string, so we can say that V by 2L is also our fundamental frequency. So what will be the delta F? So since this is 60 Hz, this is 90 Hz. So we can say that our delta F will be 90 minus 60 will be equal to the fundamental frequency. So fundamental frequency will be equal to our 30 Hz. So fundamental frequency is 30 Hz. So we can say that the frequency 60 Hz will be our first overtone or second harmonic. Why? Because this is a 2 times of fundamental frequency. So second harmonic or first overtone. Similarly, the 90 Hz will be third harmonic and second overtone. Similarly, we can say that 120 Hz will be our fourth harmonic and third overtone. So if I read the option number 1 says the fundamental frequency is 30 Hz. So yes, this is correct. The given frequencies are first, third and fifth harmonic. No, this is our second, third and fourth harmonic. So this is our wrong. Option number 3 says the given frequencies are first, second and third overtone. Yes, the frequencies are first overtone, second overtone and third overtone. So this is also correct. So from this we can say that our option number 4 will be the correct choice. Thank you students. We will meet again in the next test discussion. Goodbye. In question number 44 it says that which of the following statement is correct. So we have to choose the correct options. Option 1 says in damped oscillation total energy of oscillator is constant but amplitude is decreases exponentially with time. We know that energy of any SHM is given by half m omega square a square, right? So if the amplitude decreases, energy must decrease, so it cannot be constant. So this is our wrong. Second option says resonance is special condition of damped oscillation. No, resonance is a special case of forced oscillation. When the frequency of the driving force matches the natural frequency, then there will be resonance. So this is not the damped oscillation. In a damped oscillation, both total energy and amplitude decreases exponentially with time. Yes, amplitude also decreases, and since amplitude decreases, so energy will also decrease. So this is our correct. Option 4 says in forced oscillation, if driving frequency is equal to natural frequency, the amplitude of oscillation is minimum. No, this is a resonance condition. So the amplitude will be maximum. So this is also our wrong. So we have to choose the correct option. So we can say that our option number 3 will be the correct choice. Now let's move to the question number 45. In question number 45 it says that there are two samples A and B which contains two different ideal gas. Each sample has 1 mole of a gas. Graph between internal energy and temperature T as shown in the figure. Then we know that internal energy of any gas can be written as F by 2 nRT, where F is our total degree of freedom, right? And since in the question it says that there is 1 mole of gas, so we can write the total energy will be equal to F by 2 RT. So if I draw the graph of energy versus temperature, so it will be straight line passing through origin, and the slope of that line will be equal to F by 2R, right? So here two graphs are drawn, A and B. So we can say that from the graph that slope of A is more than slope of B. By looking at the graph we can say this. So if the slope of A is more than slope of B, so we can say that degree of freedom of A divided by 2 into R will be more than degree of freedom of B divided by 2 into R. So R by 2 will cancel out. So we can say that degree of freedom of A will be more than degree of freedom of B. And we know that for monoatomic gas, degree of freedom is how much? 3. And for diatomic gas, degree of freedom is 5. So we can say that since degree of freedom of A is more than degree of freedom of B, so we can say that A can be diatomic and B can be monatomic. Both cannot be same. Both cannot be same. Monatomic A and B cannot be same because degree of freedom of A is more than degree of freedom of B. So A and B cannot be same. So that means A may be diatomic, B may be monatomic. Now let's look at the options. A contains neon and B contains oxygen. No, that is not possible because A is monatomic, B is diatomic. But this is our opposite to the convention, right? A is helium, B is nitrogen. Again, this is wrong. A is nitrogen, B is oxygen. Both are diatomic. Cannot be possible. Degree of freedom of A is more than degree of freedom of B. Fourth option says A is O2 and B is helium. Yes, A is diatomic and B is monatomic. This can be possible. So we can say that our option number 4 will be the best answer. Thank you students. See you in the next test discussion.